Hello students, let us look at another problem where we need to get the equation of the directrix. Okay, so I think we need to understand the information given in the problem first. Okay, the standard equation of a parabola is given. So this is the parabola. Let's say this is our vertex and this is x and y. Okay. Now they're saying there is a point whose locus is another parabola. Okay, so how is this point moving? It is the midpoint of any point on the given parabola, a line joining the let's say focus and any point moving on this parabola. Okay, so let me say that again. Okay, so what are we trying to do here? The midpoint of the line segment joining the focus to a moving point on the given parabola. Okay, so the given parabola is this, so which is y square equal to 4ax, so that is given. So the focus, okay, will be a units from the vertex. So the coordinates of focus are a comma 0, and then if you take a point P on the parabola which is moving and join these 2 points with a line, okay, so you have a midpoint. Okay, so that's the midpoint. So let's call this midpoint as Q. Okay, as this point P moves on the given parabola, the claim is the point Q also moves on a different parabola. Okay, so we need to figure out the equation for that parabola and then get the directrix for that new parabola. Okay, so that means we need to first get the equation of this parabola on which this point Q moves. Okay, so Q is the midpoint of the line joining S and P. So I think we can take the coordinates of Q as x prime and y prime. So here we can clearly write x prime is x plus a by 2. So from here we can write x as 2x prime, okay, and then the a goes to the other side, so minus a. And y prime is simply y plus 0 by 2, so which is y by 2. So we have y as 2y prime. We can substitute the values of x and y in the given equation. So what do we get here? 2y prime whole square is 4a into 2x prime minus x. So now we have an equation in terms of this different point x prime, y prime. I think we can again assume that they are x's and y's. So we have a brand new equation. And if you look at it, it is a parabola. Okay, so here we have 4y prime square. I can write it as 4a into 2x prime minus a. Okay, now here understand this. So x prime, y prime can be replaced with x and y. Okay, so we are now forgetting the given parabola. We are moving to a new parabola. Okay, so how does the new parabola look like? Okay, so new parabola's equation. So we are now writing in a general, let's say, format. So y prime becomes y, x prime becomes x. So this 4 can be ignored. So we have y square is 4, sorry, 4 gets cancelled, right? So I have a into 2x minus a. And again, if I can write it little differently, so let's say I'll write y square. Maybe I'll try to write like this. So y minus 0 whole square, and this is this 2, I can bring it out. So I have 2a into x minus a by 2. Okay, so now let us, this is again not in a standard form, but I think we know the location of the vertex here. So by looking at this equation, we can know the location of the vertex. We can also know the distance of the focus from that vertex. So let us understand how to get those values. Okay, so this is what we have. As a side note, let's look at it this equation. See, if you have an equation like y minus k whole square is equal to 4a into x minus h. Okay, so this is an equation which is opening towards positive x-axis, but the origin is not at 0, 0. So when I say origin, the vertex is not at 0, 0. So here the vertex is at h, comma k. Okay, and the distance of the focus from the vertex is still a. Okay, so we can shift the origin and then plot this, okay, at the new vertex. Now if I compare whatever equation that we have obtained to this, we can see that let's say if I slightly modify the right hand side, I'm trying to write this as 4 into a by 2 into x minus a by 2. Okay. Okay, so here I have shown the parabola. So the vertex is at location a by 2 comma 0. Okay, so the vertex is at location a comma, sorry, a by 2 comma 0. Now this a by 2 is the distance of the focus from the vertex. Okay, so the focus is here. So if it is at a by 2 from the vertex, again this is distance from the vertex, so this is clearly a comma 0. Now what do we know about the location of the directrix? It is also at the same distance from the vertex as the focus. Okay, so focus is at a by 2, so the directrix should also be at a by 2. Now it is very clear, if it is a by 2 to the left, because the parabola is opening to the right, the directrix is to the left. Now you can clearly see that the y-axis is the directrix here. Okay, so if you move a by 2 to the left, that's your directrix. So that means the answer should be x equal to 0. Okay, so the directrix is at x is equal to 0. So the answer is C.